Welcome to my class 12 Physics chapter that is alternating current, and main point of discussion today that is introduction of alternating current, and before that we will discuss about direct current. We write direct current, or simply we write DC. Direct current means current do not change its direction with time. That means its direction is fixed, direction always remain constant, but its magnitude may be constant, magnitude may be constant means this type of direct current is known as steady direct current. That is known as steady direct current. Clear? Steady direct current means both magnitude and direction constant, not change with time. Similarly, magnitude may be vary or may be change with time. If magnitude may be changed with time, that means magnitude of the current not constant. If magnitude of the current not constant, then this type of direct current is known as variable direct current. This type of direct current is known as the variable direct current. Clear? And here we draw the graph. Suppose this is one axis and we draw another axis. Suppose this one is your x axis. In x axis, suppose we take time t, and in y axis we take the current, and this side is positive side and this side is the negative side. And here for steady direct current, magnitude of the current is always constant. If magnitude of the current is always constant, this is the graph. That means nature of the graph is a straight line and parallel to the time axis, so that this type of current is known as steady direct current. That means its direction is always in the positive side, not in the negative side, so that is known as direct current. Clear? Similarly, for variable direct current, we draw the graph. This one is your y axis, or that is also known as the current axis, and this is the x axis, and that is also known as the time axis. We take time along the x axis and current along the y axis, and this side is positive side of the current and this side is the negative side of the current. And here variable means its magnitude is not fixed, that is change with time. If its magnitude is change with time, just like this, magnitude is gradually increase, then decrease, again magnitude is increase, again decrease, again increase, just like this. And yet the current is always in the positive side, not in the negative side, but magnitude is not constant, so that this type of current is known as variable direct current. Clear? That means always direct current means simply its direction is not changed with respect to time. Direction is always fixed, always constant. and the symbol of a DC source, symbol of DC source, symbol of a DC source in a circuit diagram is just like this. This is the symbol of a DC source. That means one side is positive and another side is negative. This is the symbol of a DC source. And we get DC, we get direct current from your mobile battery. Mobile battery gives us direct current, and your laptop battery also gives us direct current. Solar cell also gives us direct current. Clear? Then what is alternating current? What is alternating current? We write alternating current. For alternating current, simply we write AC. AC means alternating current. Or we also write AC current. We write AC or AC current. Similarly for voltage, we write AC voltage. AC voltage or alternating voltage, AC current or alternating current. Clear? And alternating current means, first thing, its direction reverse periodically. Its direction reverse periodically. Direction reverse periodically. Periodically means after T by 2 time. T by 2 time means half of time period. Half of time period T. That means after T by 2 time. After T by 2 time, its direction is changed from positive to negative. Again after T by 2 time, its direction changed from negative to positive. That means direction is not fixed. That it changes continuously after a fixed time interval, and the time interval is half of the time period T, and its magnitude, that is the second point. Magnitude is also not constant. Magnitude also change continuously with time. If magnitude of the current continuously change with time and its direction reverse periodically, then this type of current is known as the alternating current. And we draw the graph of the alternating current. This one is your y axis, or that is also known as the current axis. We take another axis. This one is the x axis, or that is also time axis. We write that is the time axis, and this is the current axis. And this side is positive, and suppose this is the maximum value. For maximum value, we write that is I0, that is plus I0. Similarly, this is the maximum value in the negative side. We write that is minus I0. And here, this is half of the time period, we write that is T by 2. And this is the time period, we write T, because time period means simply we write T. Now you draw the alternating current. This is the half cycle, and half cycle situated in the positive side. And after T by 2 time, its direction is reverse. Reverse means current situated in the negative side. This is the negative side, and this is the wave form of alternating current. Clear? Here magnitude of the current is gradually changed. Initially magnitude of the current is increased, this is the maximum value. Again magnitude of the current is gradually decreased, and at this point magnitude of the current is 0. Then after its magnitude is again increased continuously in the negative side, and this is the maximum value in the negative side, and again its magnitude is decreased, and at this point that is also 0. That means its magnitude changes continuously and its direction is reversed periodically after t/2 time. Again this is the waveform, clear? And this is your alternating current. This is the alternating current, and this type of waveform looks like sine wave. This type of wave looks like sine wave, clear? And different waveforms are there. Different waveforms of alternating currents are there. This is the first one, that is the sine wave. We draw another type, second type. Second type, that is a square wave. Here also same thing. In x-axis we take time t. In y-axis we take the current that is I. And for square wave, this is the positive side. Again its direction is now changed, just like this. This side is positive, this side is negative. Again direction is changed, this is the positive side, and this is the negative side, clear? And here we write this is the time period t, this is the half time period, we write t/2. At this point we write that is 2t, twice of the time period. And this type of waveform, we write that is square wave. And this is also a C, this is also alternating in nature. This is the diagram, this is the waveform of alternating current. But that is wave, but that type of wave, that is the square wave, clear? Similarly another type that is the triangle wave. Here also same thing. Current, its magnitude is gradually increased, and this is the maximum value. Again decrease and situated in the positive side. Again its magnitude is gradually increased, but in the negative side, and decrease, and here current is 0. And in x-axis we take time, in y-axis we take current I, and at this point time period we write that is t, here half of the time, that is t/2, and this looks like a triangle. So that this type of waveform is known as the triangle wave. And this is also alternating in nature. This is also alternating current, clear? That means different forms are there. Different forms of alternating currents are there, but in case of your electric main supply to our homes for domestic purpose or for industrial purpose or for industry or commercial purpose, that means electric supply for domestic purpose, for industry or for commercial purpose, that is always approximately alternating in nature, and that is alternating current. Always electric supply for the domestic purpose or commercial purpose, that is alternating in nature, and that looks like a sine wave, not your triangular form, not your square form. Always that looks like a sine or cosine form, clear? And here suppose we take a coil, rectangular coil, just like this. If we take a rectangular coil and the rectangular coil suppose placed in between two magnets, two very strong magnet. Suppose this is one pole of the one magnet, suppose that is north pole, and this is south pole of the second magnet. Then you know, in air or in vacuum, always magnetic lines of force starts from north pole to south pole. That means this is the direction of the magnetic field. Direction of magnetic field in air, that is from north pole to south pole. This is the direction of the lines of force. Lines of force, clear? That means in between two poles, if we place a rectangular coil and the rectangular coil starts to rotate, if the rectangular coil starts to rotate, then what happens? Magnetic flux linked with this rectangular coil is now continuously changed. If a magnetic flux is changed, then a alternating EMF is induced. A alternating EMF is induced, or a induced alternating EMF is produced in the coil, and this alternating EMF and nature of this alternating EMF is just like a sine wave. And the equation for alternating EMF in this case is just like this, that is E is equal to E0 sine omega t. Clear? This is the equation of alternating EMF, and in sine form. Similarly, equation for current, we know Ohm's law. Ohm's law, that is V is equal to I multiplied by R. V is the potential difference, and in this case, in place of V, we write that is EMF E is equal to I multiplied by R. So that in place of E, we write that is I multiplied by R is equal to E0 into sine omega t. That implies I is equal to E0 divided by R multiplied by sine omega t, and we write finally in place of E0 by R, we write that is I0 multiplied by sine omega t, and this is the equation of a alternating current. This is the equation of alternating current. And this is the equation of alternating EMF. Clear? And here, what is I, what is I0, what is omega, and what is omega t? We write I is the alternating current, and that is the instantaneous current. Why? Because I depend on time t. So that we write I is known as the instantaneous current at any instant of time. At any instant of time t. Clear? Similarly, I0 is known as the peak value, that is the peak value of current, or that is also known as maximum value of current. That is the peak value, or that is known as maximum value, or that is also known as the current amplitude. Same thing. I0 is known as the current amplitude, or that is the maximum current. Clear? And your omega is that. What is omega? We write omega, that is known as angular velocity, or that is also known as angular frequency. That is known as angular velocity, or that is also known as angular frequency. Then what is the difference? Difference between angular velocity and angular frequency. Angular velocity means that is a vector quantity. That means magnitude is there and the direction is also there. So that this angular velocity is a vector quantity. But angular frequency, that is only the magnitude of, angular velocity. If we take only the magnitude of the angular velocity, that is known as angular frequency. And we know equation of angular velocity or angular frequency. Suppose omega is equal to angular velocity, you know its formula is equal to theta by t. Theta is known as the angular displacement, and for one complete cycle, angular displacement, that is twice pi, you know that. So that in place of theta we write twice pi divided by, for one complete cycle time taken by AC, that is known as your time period, and for time period we write capital T, that is equal to twice pi, in place of 1 by t we write frequency. And this is the equation of angular velocity or angular frequency. And what is omega t? Because your equation of alternating current, that is I is equal to I0 into sine omega t. Your omega t is there. What is omega t? Your omega t, that is known as phase, that is the phase of AC or phase of the alternating current. Omega t is known as the phase of the alternating current. And suppose one equation is there, suppose you write the equation just like this. Suppose current is I1 is equal to I0 into sine omega t. Omega t means we write same as I0 sine omega t plus 0. Omega t plus 0 means that is omega t, and here 0, this 0 is known as the initial phase. This 0 is known as the initial phase at time t is equal to 0 and x is equal to 0. X means displacement. Clear? We also write another alternating current, second alternating current. Suppose that is I2 is equal to I0 sine omega t minus pi by 2. If we compare these two currents, if we compare current I1 and current I2, one difference is there, that is here 0 is there, that means initial phase is 0. And in the second case, here initial phase is pi by 2, here minus pi by 2, not plus pi by 2. Minus pi by 2 means if we compare I2 and I1, then I2 current is lags behind a phase angle of pi by 2 radian as compared to the current I1, because your minus pi by 2, minus means lags behind. Clear? Minus means lags behind. That means simply write I2 lags behind a phase angle of pi by 2 radian as compared to current I1. Clear? Or same thing, current I2 lags behind an angle pi by 2, or you also say that current I1 ahead, current I1 ahead an phase angle of pi by 2, current I1 ahead a phase angle of pi by 2 radian is the same as current I2 lags behind pi by 2 radian as compared to I1. Clear? Simply write, if we compare I2 and I1, I2 current lags behind because minus sign is there. Due to this minus sign, we say that current I2 lags behind pi by 2 radian angle as compared to I1, or current I1 ahead and phase angle of pi by 2 radian as compared to I2. Clear? If we draw the waveform of I2 and I1, this is the waveform. We draw the waveforms for I2 and I1. This is the y-axis, or that is also known as the current axis, and this is the x-axis, and that is also known as the time axis. Suppose we take time along the x-axis. If we take time along the x-axis, then we divide the x-axis into different parts just like this. Suppose this is the half of the time period, we write t by 2. This is the time period, we write t, and this is the initial point, we write 0. In between 0 and t by 2, this point we write that is t by 4. This point we write that is 3t by 4. Clear? And if we take omega t along x-axis, omega t means, you know this formula, omega is your angular velocity, that is equal to angular displacement by time. That implies theta is equal to omega t. That means omega t means that is the angular displacement. That means if we take angular displacement or angle along the x-axis, here t means time period. Time period means time taken to complete one cycle. To complete one cycle means total angular displacement, that is twice pi radian. So that in place of t, we write here twice pi radian. In place of t by 2, we write that is pi radian. In place of t by 4, we write that is pi by 2 radian. In place of 3t by 4, we write that is 3 pi by 2 radian. Clear? And suppose this is the maximum value of current. This is the maximum value of current. In the positive side, we write that is I0. We write that is plus I0. Similarly, this is the maximum value of current. In the negative side, we write that is minus I0, and we take current along the y-axis. And this is the maximum current. Clear? And first equation of current, that is, you know, I1 is equal to I0 sin omega t plus 0. Sin omega t plus 0, that means initial phase is 0. Initial phase is 0. Initial phase is 0 means first wave starting from 0. First wave means for current I1, this point at this point, this is the maximum value in the positive side. This is the maximum value in the negative side, and we draw the, this is the maximum value in the negative side, and we draw the graph. This is maximum when angle is pi by 2 or phase is pi by 2. Again reach 0, this value is 0, again increase and becomes maximum, again decrease and 0. This is the waveform for current, for alternating current I1. Clear? Similarly for I2, this is the equation I0 sin omega t minus pi by 2, that is minus pi by 2. Minus pi by 2 means lags behind means after current I1. Lags behind means after current I1, and we draw the graph. That means minus pi by 2. Here we write the equation, that is I2. I2 is equal to I0 multiplied by sin omega t minus pi by 2. Minus pi by 2 means the second wave or current I2 lags behind and phase angle of pi by 2 radian. Pi by 2 radian means after pi by 2 radian. After pi by 2 radian means from this point to this point. This is pi by 2 radian. This is pi by 2 radian. That means the current I2 starts from this point. And you draw the waveform of the current I2. This is the waveform of the current I2 reached maximum value, again 0, again maximum value in the negative side, again 0. And this is the waveform of alternating current I2. Clear? Look at the figure. I1 initial phase, that is 0, because I1 current starting from point 0, starting from the initial phase 0, because equation is just like this, omega t plus 0, and I2, that is omega t minus pi by 2. Here initial phase is pi by 2. If initial phase is pi by 2, second wave or current I2 starting from point pi by 2. Clear? Similarly, we write another equation. Suppose that is I3. We write I3 is equal to I0 sin omega t minus pi by 2. We write just like this, and here initial phase is minus pi by 2. Here initial phase is pi by 2. Here initial phase is minus pi by 2. And we also write just like this, that is equal to I0 sin omega t plus pi by 2. If we compare I3 and I1, here initial phase is 0, here initial phase is plus pi by 2. Initial phase is plus pi by 2. Plus pi by 2 means ahead. Minus pi by 2 means lags behind. Simply we write minus means lags behind, plus means ahead. That means if we compare I2 and I1, I2 current lags behind pi by 2 radian as compared to I1. If we compare I3 and I1, I3 current ahead pi by 2 radian as compared to I1. Clear? Now I draw the graph for I3. We write here for I3, equation for I3, that is equal to I0 sin omega t plus pi by 2. If we compare these two, I1 and I3, I1 its initial phase is 0, that means this point. I3 its initial phase is plus pi by 2, that means I3 A had phase angle pi by 2 radian. That means before I3 starts before as compared to I1 starts before a phase angle of pi by 2. Phase angle of pi by 2, this is pi by 2, so that this is pi by 2 means this point. From this point to this point, this is pi by 2. That means current I3 starts from this point. Now draw the graph. Reach maximum value, this point, this is the maximum value, and again 0 and maximum value, again 0. This graph for current I3, clear? This is for I1, here initial phase is 0. This is for I2, here initial phase is pi by 2, but that is minus pi by 2. This is minus pi by 2. Here in this case this is plus pi by 2, so that for current I3 starting point is from this point. And finally we draw the waveform of I1, I2 and I3, clear? And this is all about your introduction of alternating current, and in the next class we will discuss about mean value or average value of alternating current for full cycle. And thank you.